Hi guys, welcome to our lesson entitled Longitude and Time. As you know, lines of latitude and lines of longitude are used to locate places around the world. Additionally, lines of longitude are also used to calculate time. Therefore, our lesson for today, calculating time along longitudes. Our objectives: we are learning to calculate the time of places along lines of longitude, A, east and west of the prime or Greenwich meridian, B, in the same hemisphere, and C, across hemispheres. Before we begin, let us establish some basic facts about lines of longitude. Lines of longitude, also called meridians or parallels of longitude, run from the North Pole to the South Pole. The main line of longitude, which is the Greenwich or prime meridian, divides the Earth into the eastern and western hemispheres. Important facts you need to know. Fact 1. The sun rises in the east and sets in the west. Therefore, places to the east of the Greenwich or prime meridian see the sun first and are therefore farther ahead in time, while places in the west see the sun later and are therefore behind in time. Fact 2. Every 15 degrees of longitude represents 1 hour. Fact 3. 1 degree of longitude is 4 minutes. Fact 4. The prime or Greenwich meridian is always at 0 degrees. To calculate time along lines of longitude, we're going to explore some worked examples following the outline of the objectives previously stated. Part A1, places ahead of Greenwich. Our first worked example states, what is the time in country A, located on 45 degrees east, if the time at Greenwich is 12 noon? Let us first establish the facts of this example. Country A is located to the east of Greenwich. Therefore, this country will be farther ahead in time. To calculate the time, our first step involves calculating the time difference. To do so, we're going to divide 45 by 15, which will give us 3 hours. The time difference is 3 hours. Step 2, we're going to calculate the actual time. Considering that country A is east of Greenwich, 3 hours east of Greenwich, we're going to add 3 hours to 12 noon. The time at country A will be 3 hours ahead of Greenwich, or 3 p.m. A graphical representation of country A, located at 45 degrees east of the Greenwich meridian. Our second worked example states, what is the time in country B, located on 76 degrees east, if the time at Greenwich is 12 noon? Again, our first step involves calculating the time difference. Again, to do so, we're going to divide 76 degrees by 15, which will give us 5 hours with 1 degree remaining. As you already know, 1 degree of longitude represents 4 minutes. Therefore, the time difference will be 5 hours and 4 minutes. Our second step involves calculating the actual time. Considering that country B is east of Greenwich, country B will be farther ahead in time. So we're going to add 5 hours and 4 minutes to 12 noon. The time at country B will be 5 hours and 4 minutes ahead of Greenwich or 5:04 p.m. Country B, located at 76 degrees east of the Greenwich meridian. We have just covered two worked examples for calculating time ahead of Greenwich. These next two work examples will explore calculating time behind Greenwich. Our first worked example states, what is the time in country C located on 60 degrees west if the time at Greenwich is 12 noon? Again, our first step is to do what? That's right, calculate the time difference. To do so, we're going to divide 60 degrees by 15, which will give us 4 hours time difference. To calculate the actual time, what should we do for this work example? If you've guessed that we need to subtract the time difference from 12 noon, then you are correct. We're going to subtract 4 from 12 noon. The time at country C will be 4 hours behind the time at Greenwich, or 8 a.m. Here is our graphical representation of country C located along 60 degrees west of the Greenwich meridian. Our second worked example states, what is the time in country D located on 76 degrees west if the time at Greenwich is 12 noon? Step 1, we're going to calculate the time difference. To do that, we will divide 76 by 15, which will give us 5 hours with 1 degree remaining. As already established, 1 degree equals 4 minutes. Therefore, the time difference is 5 hours and 4 minutes. Step 2, calculate the actual time. To do that, we will subtract 5 hours and 4 minutes from 12 noon because 76 degrees west is behind Greenwich. The time at country D will be 5 hours and 4 minutes behind the time at Greenwich, or 6:56 a.m. Country D, located at 76 degrees west of the Greenwich meridian. This brings us to our next section, Part B, places in the same hemisphere. In this case, calculating the time of places for the east. Our first worked example states, if it is 3 p.m. at 45 degrees east, what time will it be at 75 degrees east? Let us first consider the facts of this question. 45 degrees east is located closer to the Greenwich meridian than 75 degrees east. This means that 75 degrees east is further ahead in time. Therefore, our first step is to calculate the difference in degrees. To do that, we're going to subtract 45 degrees from 75 degrees, which will give us 30 degrees. Please note that 75 degrees east is 30 degrees to the east of 45 degrees east. Our second step is to calculate the difference in time. To do that, we're going to divide 30 degrees by 15, which will give us 2 hours difference in time. Our third step is to calculate the actual time. The time at 75 degrees east will be 2 hours ahead of that at 45 degrees east. So therefore, the time will be 3 p.m. plus 2 hours will give us 5 p.m. The time at 75 degrees east will be 5 p.m. All right, we're going to calculate the time of places in the same hemisphere, those places that are further west. If it is 5 p.m. at 35 degrees west, what time will it be at 90 degrees west? Again, we need to calculate the difference in degrees, and that will be our first step. 90 subtracting 35 degrees will equal 55 degrees. So we know that 90 degrees west is 55 degrees to the west of 35 degrees west. Step 2, we're going to calculate the difference in time. 55 degrees divided by 15 degrees will give us 3 hours with 10 degrees remaining. What should we do with this 10 degrees that remains? If you've guessed that we need to multiply the 10 degrees by 4, you are correct, and that will give us 40 minutes. Therefore, the time difference will be 3 hours and 40 minutes behind the time at 35 degrees west. Step 3, we're going to calculate the actual time. 5 p.m. minus 3 hours and 40 minutes will give us 1:20 p.m. Note that we subtract as the time at 90 degrees west is behind that at 35 degrees west. Okay, students, we have just completed part B of our objective, calculating the time of places in the same hemisphere. So we have completed calculating the time of places for the east and calculating the time of places for the west. So we have just completed part B of our main objective. We are now moving on to part C, calculating the time of places across hemispheres. So just to recap, part A, we calculated the time of places ahead and behind of Greenwich. Places ahead, you add the time to Greenwich. Places behind, we subtract the time from Greenwich. For the calculation of time and places in the same hemisphere, for those for the east, we continue to add after we found the difference in degrees. And for the places for the west, we subtract after we have also found the difference in degrees. So, part C, calculating the time of places across hemispheres. If it is 6 p.m. at 45 degrees east, what time will it be at 60 degrees west? Step 1, we're going to calculate the difference in degrees. However, for this section, we're actually going to add for the difference. It's kind of weird, right? Okay, so we're going to add 45 degrees to 60 degrees, which will give us 105 degrees. Note that we add the degree for places in different hemispheres. This is important. Step 2, we're going to calculate the difference in time. To do that, what do? Great. If you have guessed or surmised that we're going to divide 105 degrees by 15, you were right. And the difference in time will be 7 hours. The next step, what should we do? Great. If you surmise that we are going to calculate the actual time, you are right. So the time at 45 degrees is 6 p.m. What will be the time at 60 degrees west? In this case, it is important to note that since we're going back in the west, we have to subtract. So we're going to subtract 7 hours from 6 p.m., which will give us 11 a.m. Note that we subtract as the time at 60 degrees west is behind that at 45 degrees west. Now students, if we were to calculate the time in the reverse, as in, if a place is located at the west and you're trying to find the time in the east, for step 3, you're going to add instead of subtract. All right, we have covered the steps for calculating time using lines of longitude. A, east and west of the prime or Greenwich meridian. B, in the same hemisphere. And C, across hemispheres. Now, for those students who need to recap, you can replay the video. And as I stated earlier, it is important for you to take notes. That way, you can have the steps right there in front of you when you are doing your assessments. At this point, I'm going to ask you guys to complete the worksheet that is posted. And once you have completed that, there is a quiz that you must complete as an additional assessment. If you need to refer to the video, it will be available for you to go through at your convenience as many times as you like. And also, you need to take notes. Please remember to always show your work-in for your assessments and your worksheets. For the multiple choice, that may not be necessary. The fact that you get the answer correct means that you would have gone through the steps successfully. Thanks for watching and look forward to receiving your work. Bye!